This is the screencast for Statistics 243, September 19th, 2014, class number 9.
Sorry.
Oh, it's okay. I'm delaying to let people put answers up anyway, so it was a good day to be late. Thanks, Chris. All right, so we have a few things to look at for each of these. All right, so let's look at this one first. Okay, so this was fairly straightforward. We have we have a 0 or 1 for each of the C and the A, and then we definitely have the T. And then in this case, if we wanted to match only this, which I think is what I said in the problem, we need to have the caret and the pound at the beginning and the end. And then this should work, but you don't really need the brackets because the C is just going to stand for itself, or the A is just going to stand for itself, or the T is just going to stand for itself. So you don't really need it to be a character class. But that should work if you wanted to define a character class. Although in this case we would want to have the $sign and the caret here as well.
And that would match CT.
What's that?
That would match CT.
That's true. That's a really good point, actually. I hadn't caught that. But yeah, so this would match CT as well. So that's a drawback to this. Any thoughts on how we could handle that?
Explicitly not character class CT.
Okay, where would we do have a sense of where we would put that?
It has an and operator, right?
Well, we could do the or with the bar, right? Okay. So basically, what we're saying is, yeah. So we want to try and exclude this. I mean, if we made this into a character class of, let's see, how we'd have to do something like. Well, we can't do it by taking this out because then we wouldn't get just the T, right? So maybe we could take this out and then do an or with it. Actually, that one's a little more complicated than I realized. So I was thinking maybe we could do yes or no C, definitely A, and definitely T, and we could do that with or we would need to do it with, wait, what am I losing here? Or just a T. Does that look like it would do it? Anything look wrong with that?
But if you still have CT, you would just not get, you still get matched to the first one because the second one is, you're saying it's only T, right?
Well, this is only T, but it wouldn't match CT because this doesn't match CT.
Right, but so C still going to get matched to the first one.
And this won't match CT either.
So C doesn't solve the problem, right? Because we're trying to catch CT.
No, we're trying to.
No, we're trying to exclude CT.
Yeah, but CT is still going to be.
No, because CT won't be caught by this, because CT, this could be yes or no C, but it definitely has to have an A and a T. Yeah, no, it's fine. That's what we're talking about. So I think that would work. It's a little bit inelegant, but I think that would work. And so that was a good catch of, maybe that was Chris in the back who caught that. Okay, so any other questions about that one?
Does the first example on the board work without matching CT?
No, I don't think so. I think it has the same problem, which is that this could be as yes or no a C, this could be yes or no an A.
Okay.
So we could have a C and no A and then a T. Right? I guess the other way we could do it is we could do something like C or no, CA or A, or not quite sure how to do the or nothing. Yeah, I was going to try and do this and then or. What's that?
You get a question mark for that in parentheses.
For which one? Oh, for this whole thing, right, good, okay. So I could do something like this, question mark, and then definitely a T. So I think that would, actually I don't know why, I'm not sure why I have the A in parentheses there. I might need to have well, I probably don't need a parentheses around this because when we looked at the HTTP or the FTP last time, we didn't need parentheses, so I think that would work. Okay, so even for this, what seemed like a simple example, we're saying there are a couple different ways to think about doing this. All right, what about this one? We need one or more A, and then we need a C and a T wrapped around that. So here's one way of doing it. We could have used the plus operator. So this won't quite work. Why won't this work?
That's the wild card.
Yeah, so this is the wild card, but what would this match that we don't want to match? Oh, right, I see what you're saying. Okay, so, right, I was thinking of something else, but right. So this would match any character here. So this is not actually saying, the star is applying to the period and the period is matching any character. So this wouldn't actually be, that wouldn't work.
So what if I just put a star next to the A?
Right, okay, so if we used a star instead of the plus here, then that would say 0 or more A's.
Yeah.
And then we would get CT. We would match CT, which we don't want to match.
Oh, okay.
Right.
So you don't have the option of like only, like you don't have the option of using any symbol that says match the previous one or more times. It's just 0.
Well, that's what both of these do, but the star does not do it. The star does the 0 or more times version. Yeah. Okay. Any questions or comments about that one? Okay. So this one we could either explicitly give the lower or the uppercase version of each of the letters, so that would certainly work to create 3 different character classes. Or this is sort of the lazy version, which I very much like. If you can be lazy, go ahead and be lazy. Just put in dog and then say ignore case. So, great. Extra points to the person who put that one up, who had the lazy answer. All right. Now we turn to the harder ones. So I said, what did I say? Match any positive number with or without a decimal place. Is that right? Okay. So what have we got here? We have any one or more digits in front here. And then we have, what have we got here? Then we've got the digits, so we've got one or more digits here. And then I think what this person actually probably wanted to do was, I think we want parentheses here rather than the brackets. Because I think what we're trying to do is make, do a grouping where we say this whole thing might exist or might not exist. Does that sound right? Does anybody want to pitch in here with a suggestion?
That's my solution, and it was the parentheses of the two places. It shouldn't be brackets. It should be parentheses.
Oh, okay. Okay, great. So we have it from the horse's mouth, as the saying goes. Okay, so the idea is, and this is a period, right?
Yes.
Okay. So we've got this. Okay, so this is now going to be one or more digits after the period and that whole thing might or not exist. And then one or more digits either before the period, or maybe if there was no period, it might just be one or more digits there. Yeah.
Wait, so why don't you need to escape the period?
We do need to escape the period, so that's a good catch. Yep. So we need to escape the period. Okay. Any thoughts about whether there are things that anybody might catch that would make this work, or maybe mean that would work or not work? So one of the ways that I usually think about this is trying to think about test cases and see whether the test cases work or not. So what are the different ways that we could write out a number of this of this form?
Oh, it's 0.012. So just use a point sign.
Okay, so we could just have 0.012. What else could we have? Come on, guys. Yeah, except that was just for this problem. We're just talking about positive numbers.
That'd be annoying if we had
Yeah, I guess we could think about that, right? If we had pluses in front. Let's leave that out just to keep things simple. But fair point. So what other numbers are we trying to match here? Yeah, Kelly.
We could have like 1,000,000, but have commas every 3 digits.
Okay, so that would be one thing we'd want to think about is if we had commas in there, so we could have whatever number it was. I'll just leave it as even just as the thousands. Okay, what else could we be needing to be deal with?
Fractions?
Okay, so fractions might come up. Let's leave that aside and assume that would start to get more complicated as well.
Scientific numbers?
Or scientific numbers, right? So let's leave aside those sort of hard cases. And just for this problem of just like writing out a sort of more standard number, what else do we need to think about? Right, just the number 1, 2, 3, 4, right? Okay, or what else?
Number letters in front.
Oh, okay.
2, 3, 4 in the middle of like dog.
Okay.
I don't know if that was students.
Yeah, I mean, I don't think we need that probably isn't something we need to worry about here in terms of what's around it. Okay, so there are other forms of numbers that we need to deal with. What are they? Yeah, 12.34. So does that seem like it covers everything? Is there anything? Okay, so does this? So I guess we could ask the question of whether this works for each of these. So does it work for this one? Because that part of this would work, right? Does it work for this one? Okay, so why doesn't it work for that one? Because the solution was that we definitely had to have one or more of these, so it wouldn't catch this particular case of something good like that. What would happen if we changed this into a star, an asterisk? Okay, so you think it should work? I would actually say that there's a problem with it. So if I change this to a star, what's sort of the worst thing that could happen in terms of matching things?
You like match a lot of stuff, right? Because it's greedy.
Okay, well we haven't gotten to greedy matching, but that might be an issue. But if I put a star here, that could mean match this no times, and this could also mean match this no times. So I could be trying to match nothing if I did that. So to deal with this one, there might be a more sophisticated way to do it. I might need to do another one of the pipes and do sort of the other case of if it started with a period. Because otherwise, if I make this into, you can have zero of these or more, and then I make this into one of these, then I'm going to miss cases like this. Well, but what about if I put the question mark here for the period? Would that work? Suppose I had digits, and then I'll leave out the colon just because I'm going to get tired of writing it. And I had plus, and then I had a period, question mark, and then, and then I have digits, star. Does that work?
That doesn't catch point 012, right? Because you still need required digits at the start.
Say it again.
It still doesn't catch point 012 since you need digits at the start.
Okay, right. So it wouldn't catch this one. And if I change this to be the plus and this to be the star, then I would catch things like 45 dot, which I might not want to catch. Yeah, and then if we wanted to go down the route of dealing with the complication that Kelly introduced, we'd have to think about how could we deal with introducing commas in here.
Can you just remove all the commas first using G7?
Well, right. So we could go through and do some pre-processing and remove commas from any number where we find them. But we then have to recognize numbers with commas in them, right? So that just sort of pushes the problem up a level.
Can you do like a type, and then for the other one, you just do like a chunk, because it has to be in 3, right?
Well,
So it has
if
to be
it starts with like
digits.
57, you have to start counting backwards because it's not always necessary.
Right. So the complication here is, yeah, it should be in groups of 3.
But then you can do the group number, right? So we can be like multiple.
Okay. So you're saying for this part here, we'd have some sort of pipe where we then in the front here we deal with the case with all the commas in it. Okay. So that would probably be a nice solution. I mean, one of the things that would be hard. Well, the thing I was thinking of was, well, let's just make a character class that includes digits and commas. But what's the problem with that?
You just have all commas.
Yeah, you could have all commas. You could have 2 commas in a row, or you could have 4, 0, 3, which doesn't work for the for the reason Guang was saying, which is we need 3 digits in each of the groups with the commas between them. Okay, well, we could probably go on for a while about this, but I think this sort of does illustrate some of the things that can come up in these cases. Okay, so what about the 2 words separated by a white space? So we have. Okay, so this is the alphanumeric. Okay, so it looks like this one is defining a single character class, which is not quite what we want to do. So I think with this one, we'd want to have the alphabetic in a character class here, and we'd also need to have repetition operators in here as well to say that we want to have more than just a single character string. So there are a few things we would need to do with this one. What about this one here? We're saying, okay.
Can I change to a plus sign?
Okay, where do you want to put the plus?
To replace the dot and the star on both sides.
Here. Okay, great. Good. Okay, thanks. Good. So that's a good change. Okay, and actually we need. So we also need to say this is a character class. So we need to end that. We need double brackets here. We need double brackets here. And then we need double brackets here as well. Okay. So does that work? So I think we're close, but there are still a few things that we need to modify for that one. Mike? In the front? Or in the back. Okay, so we would need to have the space operator here in the front. And then presumably 1 or actually 0 or more, I think. Did I say 0 or more? Okay, so a star here. And then the same thing here. I'm sort of running out of space to put my space. Okay. A couple more things that I still see that we could modify this with to get the full solution here. So I think I said any amount of white space in the middle between the 2 words. So we need a repetition operator in here as well. Okay. And then there's something that this won't catch. If I were saying this can be any 2 words separated by a white space.
Apostrophes.
Yeah, any possessive thing where you've got an apostrophe in there. Which we could deal with by making another character class with the alphabetics. But if we try and do it that way. So what if I just stick an apostrophe into this character class and this character class? What's going to go wrong then?
Then you could catch like apostrophe space apostrophe, that's wrong.
Yeah, or I could catch multiple apostrophes in a row, or a word that has 7 apostrophes in it. A word that has 7 apostrophes in it. Right? Any thoughts about how we could deal with that?
I mean, you can specify only one apostrophe.
Okay, so yeah, so something along those lines might allow us to do it. Any thoughts on how we could go about that? So think about where apostrophes occur in a word.
Towards the end, but not always the same.
Yeah, well, that's what I was just trying to think through. Would they always be the second to last character?
Your. Y-O-U apostrophe R-E-U-R.
Oh, yeah, right. Okay, so I was about to. What I was thinking was a suggestion of like apostrophe S
Right.
as a group 0 or 1 time at the end of each of these guys here, but that won't deal with contractions where we have an apostrophe in there. So that might be hard to do. So let's actually look at this one. So somebody else had put up this. So okay, so this is another way of saying space 0 or more times. And then we have, so the /W I think is the same as alphabetic. And then we have, so this person had the solution that I was starting to go towards of including some punctuation in here as a possibility. But that does carry the possibility of catching these things that we wouldn't want to catch. So I think again, this is one where if we really wanted to deal with all the tough cases, it's sort of a hard problem, and we might have to start doing a bunch of types where we say or this, or that, or this to handle all of the special cases. So in some cases, it depends on knowing sort of what's the body of data that's going to go into your that you're going to be using the regular expression on to know whether you're going to have to handle some of these trickier cases. Like you might know whether your data set has commas in it inside the numbers or not. You might know whether it uses exponential notation, and then that will give you a sense of do I need to deal with those trickier cases or not. And I think, sort of my sense is oftentimes if you really have to deal with hard cases, you just have to step back and start to like enumerate some of the different special things that you need to catch, which isn't very elegant, but so be it. All right, any more questions or comments about those examples? I think that drew out a lot of interesting cases that we would need to deal with.
Yeah, I still have a question about the two words that are written right in white space.
Mm-hmm.
For the second expression, so you said we have to add like space in front and after. So
Right.
what if we don't add? So will it be some
Oh, right. So that's a good question of sort of this are we including things or excluding things? So I guess if we,
Yeah.
and this had to be only 2 words, so I should have actually had the caret and the $sign wrapped around these, right? I guess we didn't talk about that. So if I do have the caret and the $sign, then I would need to have this in there to allow for the fact of including cases where I have the white space either at the beginning or the end. But if I didn't have this here and here, then I may not need to worry about the space at the beginning and the end.
But the thing is that by default you will just grab 2 words that are separated by space even without having a space in front and behind, because you're not if there's no space in front or behind, then it will be 1 word.
Wait, so if there's no space in front or behind, well, it's
Yeah.
still not 1 word because we have this in here, right?
Yeah, no, it's like if you have no space in front, then let's say you have something else in front and you don't have the space between these 2 words, then these 2 words are actually 1 word. So by
Oh, I see.
default,
Okay, right.
yeah, so isn't it redundant to add the 2 spaces behind and at the back, because by default you're just trying to grab 2 words separated by a white space.
Yeah, I think it probably is redundant if we didn't have these in there. If we have these in here, then if we didn't have this in here, it wouldn't catch the case where you have space, my space cat.
Oh, so if we didn't have the space thing in front, then you wouldn't catch a phrase that is space, my cat,
Right.
space.
Right. Or just space, my cat, or my cat, space. Okay, so let's turn to a few of the, so we're sort of mostly through the main concepts we need to deal with here. There are a couple more things. I want to talk a little bit about substitution, and I want to talk about greedy matching, and I think those are the main things that we need to do to sort of finish up covering all of these different pieces of syntax that will allow us to put together these kinds of expressions. So the idea of doing replacement is we can do replacement. We've already seen replacement where we're just replacing in for some fixed string. But in this case, we want to be able to replace in for a pattern that we've found. So the idea is that the parentheses also allow us to say, to do replacement in for a pattern that was found. And basically what's going to happen is anytime you have a parenthesis, and we've seen different places where we've been using parentheses in our regular expressions here, that whatever is found in that grouping is going to be assigned to a temporary variable. So in this case, when we do this, whatever gets found as matching this pattern inside the parentheses is going to be assigned to a variable called //1. And if in our regular expression we happen to have multiple cases where we had parentheses, so is there a good one? Is there a good example here? So here's an example where we had two parentheses. And so //1 would be whatever was found inside this set of parentheses, and //2 would be whatever was found inside this set of parentheses. So what's going to happen here, actually let me switch over to R to look at this, so this problem is basically the one that I solved with, I think it was SED. I solved it for you guys on problem set 1 because we hadn't yet dealt with all of this. And because I didn't want to get you guys into having to deal with SED. But basically this is going to go through and we can, let's just parse this out. So this is going to look for a character, this is creating a character class that is not either a double quote, I guess I need 2 backslashes there. Although actually, I'm not actually totally sure I do, because if we go back to what our special characters were in the beginning part of the unit, I'm not sure a quote was in there. Yeah, so there's no quote in this set of special characters that are used for regular expressions, but on the other hand, if we use a double quote, the R is going to think it's ending the pattern, because we're specifying the pattern as a string. So I think maybe that's why I just have a single I think that's why I had a single backslash here, is I'm just escaping the quote to say this is used literally as a quote, but I'm not doing the double backslash, which is dealing with the special characters in the regular expression syntax. Okay, so this is saying not a double quote and not a comma, anything that's not one of those, followed by a comma. And then what this is doing is saying replace in for that pattern whatever was found as the first piece, the thing that was not the comma or not the quote, replace in for that. So what this is going to accomplish is stripping out the commas for places where I have a comma, where the comma comes after something that's sort of substantive. But the reason I had to do it this way is I didn't want to replace in, so this is a comma delimited file, I only want to replace the commas that are inside the fields, like inside the person's name or inside the number here. I don't want to replace any of the commas that have a quote before them, because that's the end of the previous field. And I don't want to replace any commas where it's another one comma followed by another, because that just indicates an empty field in the comma separated file. So this was my solution to try and deal with that. And I think I've tested this in more than just this one line, and I think it works pretty well. But there might be something that one of you might catch that would mean that it wasn't quite a sufficient answer. Okay, so in this case, I needed the //1 and I needed the parentheses here so that I was able to pick out just this piece of what was found, and I wanted to basically replace the comma, but to do that I needed to keep this piece that was the substantive piece before the comma, so that I could basically just strip out the comma. Any questions about that? Okay, so if I do that, and now I do the G, so this is going back to, I should have used this, I guess I've got both answers in here. So this is using the older base syntax, but let's do it using string replace, because that's the one that we've been focusing on. Okay, so now I do it with the string replace, and hopefully that worked. So I did it with the underscore all, so I could replace all of these, and it looks like I did indeed pull out the comma from the Gary Ackerman, and I pulled out the comma from the 13242, but I've kept the 3 commas here, and I've kept each of the commas that are between, that are actually separating out as serving as the delimiters. All right, so any questions about that?
What does the double backslash mean?
So that is the name of the temporary variable in which whatever is matched here is placed. So this is referring back to whatever was found in here as the pattern that matched here, as the string that matched this pattern. Actually, is probably a better way to say it. I guess I could. I mean, in some sense, I can print it because. Yeah, that's a good question. I mean, I can sort of see what happens. I sort of see what gets printed out because I can see what wasn't removed. Like if the n had been removed before the comma or the 3 before the 2, then they wouldn't have remained in there. So that would be one way to see it. I'm not sure if there's a good way to print it out sort of more explicitly. Anybody have any thoughts? There might be a clever way that I'm not seeing at the moment.
Why this comma is replaced by space?
It's not replaced by a space, right? Because this comma just got replaced. So basically, it found the 3 comma and replaced it with just the 3, and so that's why the 3 is still in there. And it found the n comma and replaced it. So it found the n comma, but only the n is here and the comma is here, and then it replaced the n with itself. It replaced the n with the \1, which is the n. Other questions? Yeah, Chris.
I just thought it was unfortunate that our federal government is putting out CSV file comments inside.
All right. Well, I think there are probably more important problems with our federal government, but your point is well taken. Yeah, you will find that it's not just the federal government. The quality of sort of data sets and data formats on the internet for what should be fairly official data sets is often pretty abysmal. So this is by far not the worst of the things that you will see as you look at data sets out there. Okay, so I think actually to sort of reinforce this point, let's look at a little problem and see if you guys can come up with a solution for this. Okay, so here's what I want. Here's the challenge for you guys to think about for a couple minutes, and then we'll see if we can arrive at a solution for this. So suppose I have a text string where there are dates like August-3 and May-9, and what I really want to do for some reason is reformat those so they look like this: 3 space August and 9 space May. Try and take a couple minutes, feel free to confer with somebody next to you and figure out how would you use the string replace function to detect these guys and replace them with something like this, where I'm basically reversing the order of the different pieces. And you can assume it's always going to be 3 letters, and it's always going to be a dash, so just to make it a little bit easier.
What does if \1 is the thing that's right before the comma, then what does \2 mean?
\2 would only be relevant if I had 2 parentheses in the regular expression, and then whatever was matched in the second set of parentheses would be put into \2, double \2. If I had some regular expression like this one where I had 1 parenthesis and a second set of parentheses, double \1 is going to get assigned to whatever this was found for here, and double \2 is going to give you whatever was found for here. All right, somebody want to start me off here? So what am I looking for?
Some alphabets and then a dash and then some digits.
Yeah, let's be a little more specific in this case. There are only a limited number of things that we're actually trying to find. They're not just alphabetic, but very specific month names. What's that?
Just release all of them into the regular expression.
Put all of the month?
Yeah.
Okay, so how would I do that?
Square bracket, and using the square bracket, it's just list out all of them.
Okay, so you want to list out all of these like this?
Yeah.
Okay, so it's not going to be a square bracket because we're not making a character class, right? Well, but a character class is just going to match one character. Yeah. So what else can I do here to say one of these or the other or the other? The pipe. So I can do something like this. I'm not going to write them all out because I'm getting tired of typing already. But okay. So now what else do I need? What else do I need to do now?
Brackets.
Hmm?
Do you need brackets around this?
Okay, so but not brackets, but parentheses. Okay, so I need to say any one of these things, and then what do I need to do?
Dash.
Then the dash.
Digit.
Actually, I think I might need, that might be one of my special characters. I might need a double backslash and a dash.
Not necessary.
Huh?
That you
I don't? Oh, okay. All right. Yeah, I guess maybe the dash only gets used in the square brackets if we do like 0 to 9, so maybe that's why we don't need it. So how about for the digits? Okay, 1 or 2, so a character class and question mark. And then I can do digit. So does that look right? All right. Does anybody see any problems with this so far? Does that look good? Yeah, Tibo? Say it again. Oh, I think it wouldn't because that's why we've got the character class that says 1 or 0, 1, 1, 2. But it could catch. Oh, I need a 3 here, right?
I meant like 1 or 2 digit characters, not the numbers 1 or 2.
Oh, I see. Okay.
Sorry.
Okay. Well, the reason I had been thinking about doing something like this, which is why when I heard what you said, I misinterpreted it because I was thinking of something else in my head. Yeah, so I could try and do this, but then it gets complicated because I could catch 37 or 39 or something. So I could go with Kelly's solution of saying 1 or 2 digits. That would also miss things like it would catch 79. I mean, it would catch things I shouldn't, like 79. Okay. But let's assume that there aren't any of those things in our data set and that we're going to ignore that complication. Okay, so if I've done this, now let's turn to the replacement part of the problem. How would I deal with doing the replacement? Because I basically want to switch the 2 pieces, right? So how would I do that?
Backslashes and then 2 and then space backslash.
Okay, so backslash 2, space backslash 1. So that's what we need to do. There's something still not quite right in here that I missed when I was filling out the first part. Okay, so backslash 2 at the moment isn't actually going to be filled because there's only one set of parentheses. So I need to put a set of parentheses around this. Okay, so now we have, it's a little bit unfortunate because it's sort of split up in an awkward way. Let me just remove the name of the function for the moment and maybe that will help us. So this is coming along and say, okay, I'm trying to match this dash this anything, whatever gets matched here is going to be put in //1. Whatever gets matched here is going to be put in //2. And then I'm going to replace whatever this whole thing that was found by the second piece space the first piece. So that will do the reversal.
So I guess last digit class you may notice this. You should add a question mark
Here?
Yeah.
No, because
you can have the first day of the April, something like that.
yeah, but I think that will match because this could be 0 or 1, and then that would match with the 1. So I think it's okay. Okay, so any questions or comments about this replacement? Okay, so the last thing I want to say is talking about greedy matching, which somebody had mentioned before and is something that we need to be concerned about. So here's an example where greedy matching comes in and bites us. So this is some HTML code that just has, I think, is B bold in HTML? Does anybody know off the top of their head? Yeah, okay. So this is writing out HTML where this is HTML where this is going to be bold and that's going to be bold. And our task might be to strip out all of the HTML tags from a document because we want to convert it into plain text. So maybe that's what we want to do in some particular context. So I come along and say, okay, I know about regular expressions. I can handle that problem. I'm going to look for any of these less than or greater thans and look for 0 or more of anything that's in between those and just replace it with nothing. So I'm just going to try and find, let's see, what am I, yeah. I guess, okay, let me define my problem as I'm just trying to strip this whole thing out and not replace this back in, but using what we just talked about with the //1, I could have put the //1 in here, for example, and replaced it there. Well, that would have been hard if I was then trying to replace multiple entities. But just for the sake of illustration, let's assume I'm trying to take out everything that starts from here and ends here, as well as what starts here and ends here. And then I try and do it with this particular expression. So if I go ahead and do that, what I'll see is that this turned out to be a greedy match. And so what it did was it went up to here. It found from here, and what it looks like is it pulled out everything all the way up to course. So basically, it matched all the way from here to here and replaced that with nothing. And the reason it did that is because by default, it's going to do greedy matching. And so it comes along, it finds this, and then this says match 0 or more of anything up until you get to here. Well, I keep going along, and this thing actually can also match to being inside here. So then it keeps going along, It gets to, and all of these still qualify as matching any character here. So does this, for that matter. So does this, until finally I get to here, and this is the last one of those. And that then matches as here. And so it strips out the whole thing from here to here. Okay. And that's greedy matching. And this, for example, this comes up all the time. It'll probably come up when you're working on the next problem set that you realize you've done a greedy match and you didn't mean to do a greedy match. So one way to handle that is to use the question mark operator in a different way than we've already been using it, just to add to the complexity. Just like the caret could stand in for 2 different things, the question mark can also stand in for 2 different things. And if you do something like this and you put a question mark after something like this, this will say don't be greedy in doing the matching here. Only find the minimal number of characters that I can find, and then go find the greater than sign. So this will actually work, and it should just pull out this one and that one. So if we go ahead and do that, we should see that works. That pulled out.
Pulling out only the tags, right? Because it's really not greedy, so it's as small as possible.
Oh, right. Okay, sorry. That's why I got confused before in terms of defining what the problem was. Is I got confused and was thinking I was trying to pull out this whole thing, but what I'm really trying to pull out, which makes more sense in the way I originally phrased the problem, thank you, is I'm just trying to pull out this and this and this and this. I'm just trying to pull out the HTML tags. Okay. All right. So now that hopefully that's now clarified. Okay. So this matched this and pulled it out. It matched this and pulled it out. It matched this and pulled it out. It matched that and pulled it out. And it wasn't greedy, it just came along, and once it got here, it said, okay, that matches to here. And once it got here, it said, oh, I'm not being greedy, that matches to here. I'm done. I found a pattern, I'm going to replace it. and then it just keeps going on because I'm doing the underscore all. So that is let me just ask one more question, which is we could actually be a little bit more clever about doing this and not even use that question mark in our regular expression to avoid the greedy matching. So anybody have any ideas of what we could have done, what we could do instead of this what we could do instead of this without even using a question mark at all to be a little bit smarter and avoid the greedy matching? Yeah, Alex. Okay, so one possibility would just say I just want one thing in here, except for HTML tags, that there are going to be HTML tags that have more than just one character in them. So that. Oh, yeah, that won't quite work because it's not like I'm looking for double closings. It's that I want to make sure I'm not matching the closing in here. Because if I just say that there can only be, I mean, this is already saying there can only be one of these, just because I literally have it in there. Yeah.
Any number of characters in the middle excluding space, because as far as I know, HTML doesn't allow spaces.
Okay. So we might try and redefine what goes on here as not any character, but only certain characters, which could go down the route of you're thinking about spaces, or we could define a character class in here that says anything that's not one of these. Right? We could say anything. We could say a character class that is. We could do it as not the open bracket, and then we could have this, and then we're saying any number of these, and then this. So I think that should work because that says this can be anything in here except one of these. So when I get to one of these, it wasn't matched by being in here. It's just matched by being at the end. So with the greedy matching, sometimes you can use this, but sometimes you can come up with a more elegant way to get around it.
So the question mark always comes after some sort of wildcard or plus, right?
What's that?
Oh, as in to avoid the greedy matching, you basically put the question mark after a wildcard or a plus.
Yeah, that's usually where it would come up, I think. Right. Okay, so we're over time, so let's finish up here. We're going to do a bit from Unit 5 on debugging as a demo for debugging on Monday, and then we'll also start in, if I have time, I'll start in on Unit 6 as well on Monday. And the problem set is due on Monday as well, as you know.
Yeah.